Hello class, welcome to our lesson today dealing with section 2.1 and 2.2, dealing with frequency distributions. What you'll notice in this, in your Prob-Stat book, is that section 1 of each chapter is just a review, so I kind of will morph that in to section 2.2 today. We're going to go through what a frequency distribution is. You'll want to pay attention to, there's 3 types of frequency distributions that you need to be comfortable with. And some terminologies about the frequency distributions that you want to make sure that you understand. First thing to look at is characteristics of what data is going to be looking like for us. There's 2 main characteristics that really starts the whole realm of statistics, which is the measures of center and the measures of variation. So measures of center say where the middle is, think about the center of something, and the variation says how far apart of the numbers or how widely spread out are they. Okay, those 2 main characteristics are what a lot of statistics is based on, and we're going to be looking at that as we keep moving forward in the semester. Next thing about statistics is the distribution. So there's lots of different types of distributions that could be used in statistics. The one that you'll probably see the most often is what's known as a bell-shaped curve. So that kind of starts low, goes high, ends low. Okay, so maybe you've heard of bell-shaped curve before. That's the one that we're going to talk about the most. A uniform distribution is one that where everything's similar. So that'll kind of be like there's the same amount of in each category or each number. And then skewed could say there's a lot more of one type of number versus the smaller numbers, so a lot of larger numbers versus small. And instead of like a bell-shaped curve, it's kind of shifted over and makes kind of a hill on one side and kind of a valley on the other, or a small slope. Outliers, numbers that or data points that are really far off from everyone else, are known as outliers. There's systematic and mathematical ways to determine if something is or is not an outlier. For now, we probably just want to be able to do the eye test, which is, okay, let's look at this. Oh, that number seems really far off. If there is an outlier, it's that one. That's something that you want to be looking at. And then time also can be used in statistics because you could be looking at, like, say, medicine and how it affects you as time goes on. That's just an example, but time is often used in these situations as well as the variable that is being looked at for different data collection. Okay, we're going to spend a lot of time here on what's known as a frequency distribution, and it's this table right here. This is a frequency distribution, and what it is it groups sets of data. So like this is from 40 to 49 degrees, 50 to 59, etc. And then says how many are in that category. Essentially, you can think of it like a bar graph, but in a table format. Okay, so it's saying there's 9 of this group, 13 of this group, etc. And anytime you're dealing with frequency distribution, it's kind of the category or the range of numbers, and then how many are there. Okay, and there's a lot of different pieces dealing with frequency distributions that we need to discuss. Okay, one of those things is what's known as the lower class limit. Okay, the lower class limit is the lowest number that is in the class. Now, a class is just each of these columns or each of these rows. Like 40 to 49, that's one class. 50 to 59 is a class, etc. So the lower class limit is the first number that's in the category, which would be 40, 50, 60, etc. And on your homework, you have to kind of type all those in with commas. So it'd be 40, 50, 60, etc., all the way down to 90. Upper class limit would be the upper end of the class, which is 49, 59, etc., all the way down to 99. The class boundaries are the numbers that dictate which class you end up in. Because here's the issue. What if the temperature was 49.7 degrees? 49.7 is more than 49 but less than 50. But the frequency distribution has to cover all the numbers from the range of 40 to 99. And so what happens here is it's just a basic rounding principle. Take the upper class limit and the lower class limit of the next one and kind of average them, and it's 49.5. One thing that you want to make note of is when you do your homework that the first class limit should be below 40. Okay, so I've only written here this 49.5 is my first one, but there should be a 39.5. So 39.5 is the first one, then 49.5, 59.5, etc. And it keeps going down the list. You'll notice that each of those kind of go up by 10. Notice each of the lower class limits go up by 10. Each of the upper class limits go up by 10. Okay, that's not a coincidence. Okay, because that's what's known as the class width. So I'm going to skip down to this class width right here. That's the difference between two consecutive lower class limits or upper class limits or class boundaries. And all classes should be the same width. So think of it like a bar graph situation. You want this distance to be the same as this distance, etc. Same idea here. We want the distance from lower to upper to be similar every time so that we can actually look at the distribution and of the frequencies to tell what's going on. So, class width, you can use the lower class limits, upper class limits, or class boundaries. But make sure you know that 39.5 is the first one. So when you're looking at your homework, the first lower class limit should be 39.5. Other thing is class midpoint. So that's just an average of the upper and lower class limits. So 40 plus 49 divided by 2 would be 44.5. Then 54.5, 64.5. It's very repetitive. So when you're going over your homework, you'll notice there's probably more questions to look at for this section, but there's a lot of repetition involved in those scenarios. The next type of frequency distribution that we need to be comfortable with is what's known as a relative frequency distribution. Okay, you'll notice here that this looks pretty similar. This first column here is temperature, and it's 40 to 49, 50 to 59, etc. That part looks identical to the last slide. What's different is instead of frequency, it has relative frequency. Now, relative frequency, if you think about relative, how you're related to something else, okay, relative frequency basically saying, well, how much of the group is in that category, and it's in a percentage base. Because often if I give you these numbers, this doesn't really stand out to anyone. Yeah, sure, we know 17 is the most and 8 is the least, but as soon as I take it and make a percentage, okay, all of a sudden you can say, wow, almost a fourth of them are in this category. We find this by just adding up the frequencies. So if you add up the second column here, you'll get 70. And then take the number, which in this case would be 9 divided by 70. And then I round it to the nearest tenth of a percent. That's probably a common practice in a lot of these cases. We don't want to keep taking this decimal or this percentage all the way down 10 places or something crazy. We also don't want to round to the nearest whole number because 11.7% is a lot different than 12.3% depending on the situation. So you're just going to take each number. So this would be 9 divided by 70, 13 divided by 70, 8 divided by 70, 17 divided by 70, etc. And you just divide them all out and figure out what those percentages are. The third version of a frequency distribution is what's known as a cumulative frequency distribution. If you think about accumulation, you're kind of adding things up as you go. Okay, so the difference in this one is it's basically a less than scenario. Instead of doing 40 to 49, you say how many are less than the next barrier, which is 50. Okay, so anything less than 50, there should be 9 of them because there were 9 from 40 to 49. Next, I go to less than 60. If it's less than 60, there should be 22 because it should be the 9 from the 40 to 49 plus the next 13 from the 50 to 59. So essentially, you're saying, okay, how many are less than 50? It's just this one. How many are less than 60? It's both of these. How many are less than 70? All 3 of them. You just keep adding on and on and on until you get to the very end. And you'll notice here that eventually less than 100, that's all the data points, and there should be all 70 data points. This idea could be useful if you're trying to say, well, how many fit into a category up to a certain point. So for a class example, I could say, well, how many A's do I have? How many B's? How many C's? How many D's? And how many failures? Okay, in a class situation, that would just be more of this frequency distribution table. If I want to know what percent of my class had each of those grade categories, it would be this version. And then if I accumulate and say, well, how many got A's or B's or C's or this, and I keep adding them together, and eventually I'll get to all the classes. So those 3 frequency distribution tables and setups are what you need to make sure you understand. Your homework has some practice of these things. You want to make sure you understand all 3 of them, how to set them up. You're going to have to do that as we move through this chapter in Chapter 2. Okay, back to the bell-shaped curve. Frequencies that start low and have a lot in the middle and then low at the end are a bell-shaped curve. So a normal distribution is the same idea as a bell-shaped curve. And so to be a normal distribution, it doesn't have to be perfectly symmetric. It just has to be roughly symmetric. So for example, if the first number is 3 and the last number is 2, that's not a big difference, and it's okay to have some things that are a little off because data is not going to be perfect when you're collecting it. So normal distribution starts low, a lot of frequency in the middle, ends low, and that's the same idea as a bell-shaped curve. Okay, if we had to create a frequency distribution there's going to be some information given to you. They're going to tell you something like, okay, you start with a lower class limit of something with a class width. Okay, so I'm saying start with 50 as your lower class limit and then make the class width 20. Now, if you were collecting data, no one's going to say like, oh, you should start with 7 or you should start with 50. Okay, you're going to have to look at your data and say, how are we splitting this up? Okay, so for like grades, we separate that by like 90% to 100% or 80%, and et cetera, et cetera. In this case, we're going by 20s and starting at a 50. I made a note here, you may want to order the numbers because you're kind of have to make sure you count all of them as you go through. You could also cross out as you go. That's easier to do on paper or if you have a digital way of doing that. But you want to make sure that you're collecting and ordering if needed, or you can kind of cross out the numbers as you go to be able to find those answers. So let's get this set up right. If the class width is 20 and I start at 50 for my lower class limit, what you'll notice here is it's 50 and then 70, 90, 110, and 130. Notice each of my lower class limits go up by 20. And that's always kind of like one less for this spot. So it's one less than 70, so 69 here. And then one less than 90 is 89, 109, 129, 149. Once you get into a rhythm, you kind of get those set up very quickly. My suggestion would be make sure that that column is set up first and then figure out how many are in each group. So make sure this category is set up, these pieces are set up, and then figure out how many are in each group. And that's literally just go through the list and see how many fit this category. Go through the list, see how many fit this category, et cetera, et cetera. This is roughly symmetric because here's what you'll notice. Small amount, larger, largest amount in the middle, going down, small again. Notice it's not perfect. If it was perfect, it'd be 3 and 3, and then maybe 7 and 7, and then 12 or something like that in the middle. But they're pretty close. 3 and 2, 6 and 7, 12. There's no like set justification if it's a normal distribution or not right now. Okay. If it looks close, it's probably yes. Okay. So when you're dealing with normal distributions, starts small on the two ends and gets larger as you get to the middle, and that's the bell-shaped curve that you're looking for. All right, that was a lot of information. Let's recap a few things. 3 types of distribution tables. Make sure you understand how to set them up. You're going to have to be able to do that on your homework and your test. And then also make sure you can interpret as needed. Remember, relative frequency distributions are the percentage ones. Cumulative, add up as you go. And a regular distribution has the class widths, just similar to a relative distribution table, class widths, and then go from there. Now that we've looked at all those things, I'm just going to show a few different types of tables. And I just want to talk about a few things about how they're set up and what we notice about them. The first one is not a frequency distribution as what we've done previously in today's lesson, because this is just categorical data. Okay, this is just categories. It's not this 40 to 49, 50 to 59 scenario, but it gets the same idea. Okay, it's still a frequency idea, which correlates to a bar graph. Okay, this would probably be shown that way. A conclusion here about blood type is there must be a lot of people with type A and type O. I'll leave it to you to figure out if that is actually the case or not, to be able to cross-reference with what type of blood is most common. If you've given blood, you probably know what type of blood that you have. And if you have a more rare type of blood, they probably are asking you a lot more to come in because your blood is probably more scarce, that type. So that's something to think about when it comes to this type of situation. We couldn't do a bell-shaped curve situation here because the data is not numerical. Okay, since these are just categories, we could do a bar graph or something like that, but it couldn't be a situation where we just can say it's a bell-shaped curve. The next one is a frequency distribution table. So notice the weights are from 4,000 to 4,099. Notice each time it's going up by 100. So the class width is 100 with a lower class limit of 4,000. The frequency is how many fit that category. So the last column, if I just got rid of the last column, that's a frequency distribution table. If I get rid of the middle column, or at least have it and then find the percentage, that's the relative frequency. The conclusion here has got to be something's up. This is weights of trucks. There's a good chunk of trucks in this lower category, and then it jumps. There's nothing in the middle, and then there's some in this higher category. That clearly means there must be 2 different versions or different materials used, or something is happening to allow these 2 types of the same model of truck to be weighted differently. Okay, so what we're looking at is the smaller ones, maybe they have a different type of aluminum that they're using that makes it a little bit lightweight but gets better gas mileage, whereas the other one's more rugged and gets a little bit worse gas mileage, but holds up a little bit better. Okay, so there's clearly a gap here because of the zeros in the middle. Side note, these zeros have to be here. You can't just go from the 4100 and skip all the way down to 4500. If there's zeros in the middle, you have to keep the class width consistent and keep going. And that's something that you want to make sure of in this situation. The next one is pulse rates of male patients. What you'll notice here is I'm only looking at the last digit. Now, to be honest, I don't know why we would ever look at the last digit. It's just to showcase a point here. Okay, the last digit of your pulse. I don't know, okay, why we were collecting that, but here we go. So if the last digit was 0, that means your pulse was maybe 70, 80, etc. Okay, so there's 8 of those people. Notice if the last digit is 1, there's none. 2 has 11, 3 is none. Notice all the ones that have 0. 1, 3, 5, 7, 9. All of the odd numbers have no pulse rates. Now let's think about this. I'm not a nurse or a doctor or anything in the medical profession. Is it possible that your pulse rate could be an odd number? And the answer is yes. However, when you're looking at pulse rate, it's made in such a way and set up that you don't take your pulse for a full minute. You take it for a smaller amount of time, and then let's say you take it for 10 seconds, and then you would multiply by 6. Or you take it for 30 seconds and multiply by 2. So what happens here is even though the pulse rates appear to be even numbers, the reason for that is how the data is collected. So that's something that you want to think about for this situation. The next one is cumulative frequency. What this would be showing is how many of the women in this case have cholesterol levels up to a certain number. So cholesterol levels less than 180, less than 190, 200, etc., all the way down to 250. A conclusion would be, okay, of the 30, so many have a cholesterol level less than something, and then there must be this gap here, okay, because it went from 26 and then nobody here, and then to 30. And if you were involved and knew more about cholesterol levels, you could kind of say, well, this is the cutoff for what's okay, and everyone past that, it would be not a good situation for your cholesterol level. Okay, that was a lot of different information. I know that was a longer video. You want to make sure you know the 3 types of frequency distribution tables, how to create them yourself, which is the most difficult part, how to set up the columns, and how to set up the relative frequency distribution, cumulative frequency distributions, and how to get those things set up in a table format. Have a good day, everyone.